we're started. So, no crayons on the carpet. That's your lesson for today. If you take away nothing else from today, do not color on the carpet with crayon. It will never come out. There you go. Let's see. Today is Tuesday, so happy garbage day to everyone. And I put up your next formative assessment, so that is available for you whenever you'd like to tackle that. It's a mix of, essay questions and then correct the ChatGPT again as a fun exercise. So we can see what AI gets right and what it doesn't get right. And in this particular set of answers, all the extra stuff it's stuck in as an answer to the question, that it's irrelevant. So that's another thing that it does, is sort of throw everything at the wall. We have, let's see here, I gave you feedback on your project revisions, so you all should have received that over email. Let me know if you still have questions on what to do, and please let me know if questions come up as you start working on things. Everyone knows when they're scheduled to go, right? There's no mysteries. And you saw my plea over email to get as many of you here in person, because there's nothing more awkward than teaching to an empty classroom. So for the sake of yourselves and your peers, if we could get a cohort together that is actually in person and listening, that way we can all talk to each other and see each other, and it's not this sort of like, bimodal experience, that would be ideal. I will be parked in the corner, and I will be giving you signals for how much time you have. So I'll be doing the thing like at conferences, 5-minute warning, 1-minute warning, all that kind of stuff. Let's see here. We were about 2/3 of the way through example 5A. I think that's where we picked up on. Any questions you want to ask before we dive back into stuff? Any lingering questions or thoughts, clarifications? Not so much? All right, how about we dive in? The water's warm. Do you remember the story for this example? It's a level 1 mediation model in fluctuation data. So we're looking at, I think it's 5 repeated measures over a week of whether or not you had a stressor that day, how grumpy you were that day, and the number of physical symptoms that you experienced that day. So that is why, as foreshadowing, we go back to the picture here, there's no change circles in the picture because there's no change in these data. So daily diary kinds of things typically would not have a strong effect of time as part of the model for the variance. It wouldn't be necessary. If this were an intervention study or something like that, then that would be a different story, but this is just observational. We're asking people questions and seeing what they say. So the next example, 5B, will tackle the other type of longitudinal model in which there is change, and more importantly, random change. That's the thing that makes it different. That's when you need to have the circle, not just fixed change. But today we're just talking about intercepts and residuals. So because person mean stressors is binary, I'm leaving it as a box for right now. I did find the example that I built using Bayes where these are circles instead. It's in the download folder. And I think it's like step 1 as Bayes or something is what it's called. So it was in there. So it will let you do that to pretend this is an outcome, even though it's being used as a predictor, and put the link function on it since it's a binary variable. So if you switch to Bayes, it will work. If you try to use ML, it will not. I will also show you at the end of this handout, though, how to do the same thing as single level SEM. Meanwhile, negative mood is circles because it's both an outcome of stressors and it's going to be a predictor of symptoms. And symptoms is the grand outcome of this, so it is a circle no matter what. First thing that we did was look at X to Y and treating that as observed variables. So this is a constant-centered version of the model because we have the original binary stressors in at level 1. We have person mean stressors, so that's the PM stress 40 variable there. It's centered at 0.4, so the average reference point is someone who had a stressor 2 days out of 5. So at this point, the code over here in mixed and Elmer and the code over here in M+ rendered the exact same model. It's the same thing. Where that doesn't happen, then, is once you switch from boxes to circles. Then it's analogous, but it's not going to be the same. So we looked at that last time as well. Do you want to go back over step 2A, or are we good with that? Because we're going to build the whole model by the end of the day today. Good? Or no? This is the part where you respond. Go over, 1 vote for go over, 2 votes for go over. No one wants to admit they want to go over it. Is that it? Are you afraid your peers are going to be mad at you? They won't, right? It'll be fine? Okay, good. They won't go over. All right. So let's go over then. So in this model, we have two outcomes. One outcome is predicting another, but they are both outcomes, and that's how I know that they are circles. Because I am not using person mean centering or constant centering and any of that to try to carve up the variance in negative mood as a predictor. I'm letting the model do that via latent variables. Do you remember what that is called when the model does it? We have person mean centering, we have constant centering, and there's a third one. What is this one called?
Latent centering?
Hey, there we go. You can also call it, what did Lütke call it? The multi-level manifest covariate versus latent covariate. Yeah, manifest was the word that was used, meaning observed. I know, it's a lot. But there's a few other synonyms that are floating out there. I like latent centering because I think it's analogous in terms of how to think about it. And we're just building a random intercept and a residual. So I could say that both symptoms and mood have been latent centered. Like normally we would call this a random intercept model for symptoms as an outcome. We can also think of it as latent centering because we have at the within model references to the variables. Those are variances. And if they're in the within model, then we know that they are level 1 residual variances. So this would be like the diagonal of the R matrix. I am setting up a placeholder for creating a brand new variable in the model here. The variable is named within person M to Y because that's what it's going to contain. It is going to contain the level 1 slope of how mood predicts symptoms. So because this is now a variable, like this is beta 1 essentially, conceptually, we can then refer to it in the between model down here. So we are giving it a fixed effect in the brackets. That's a default. I am labeling it so that I can do math on it. And then at 0 means that variable has no variance. It is a constant. So we would say that the effect of mood predicting symptoms at level 1 is fixed only. Stays the same for everybody. In these data, I did check random slopes and none of them were needed, so we don't have that. In practice, if you wanted to ask if this needed a random slope, you would remove the at 0, estimate the model, and then compare to an alternative model in which it's kept at 0 instead. I would have to add one more thing, though, if this were random. When we add a random slope, what comes with it? Covariance. So in M+ code, that would be within person M to Y with, and then it would probably be symptoms at a minimum, potentially with mood as well. So it would be up to 2 covariances. I would say symptoms for sure, mood possibly. Then these are, nope, too much. Stop it. There we go. These are between person effects of time invariant predictors of age, sex, and their interaction. And I know that they have to be between because that's the only possibility. There is no level 1 version of these that it could become the contextual effect over. In contrast, mood 2 here, because of this error message down here, is cluing you into that. And because I use the placeholder notation with maximum likelihood estimation, this has to be the contextual effect. So I can add them together to get the resulting between person effect by using these labels that refer to the estimated slopes and then making M+ do the math for me. It will then compute standard errors as well and a hypothesis test for that. So then we got to the output, and I wanted to show you a different version of a level 1 slope. This is 2b. So the difference, this is the same model, it's equivalent, but it changes what things mean. I'm not using a placeholder anymore. I am putting that slope directly into the within model and treating it as fixed. So there's no more within person M to Y stuff in the between model because it's a variable that never got built in the first place. So just as we had above, only a fixed effect and no random effect. It's referred to in the level 2 model in this way of writing the code. It is referred to directly in the level 1 model in this way. It is the same model. But because it's in the level 1 model without the placeholder, it's using latent centering to predict basically the E part of mood is predicting the E part of symptoms, not the whole variable. And that's why what used to be the contextual effect switches to between. And this is the thing that took me a while to figure out, and I never would have done it had I not had simulated data where I knew what the answer was. So this is a general strategy that you can use, and I've done this many times, like to test myself. Make up data where you know what the answer is and see what you get back. If that sounds like, what? I don't know how to do that. Use a program that you know how it works and then try to get the answers to match across programs. That's how I figured out most of R, is by running things in SAS and then trying to make R cooperate to give me the same numbers. So there are strategies you can use in real life to try to figure out how things are working, but sometimes it takes more effort than others. Okay, questions so far? Do you remember when you can set it up as a level 1 fixed effect directly in the within model versus when you need to do it this way with the placeholder notation? When is that version that I have highlighted right here required? If you only want a fixed effect, you can do it either way. However, what's an alternative?
If you want something random in there, like a random slope or something.
Yep, random slope, and what else? Once we have a random slope, what do we do with it? Yeah, cross-level interactions to predict it. Why is it that some people might have a greater effective mood on symptoms? Is it because of their gender or their age or their personality or other kinds of level 2 people things? Could be. To do that would require putting them in the model. And I think I have an example of that in this handout so that you have a template to follow in that case. Hey, another rumor. Kendall's here. I'm doing the thing where I announce where everybody is. So, hi. Yeah, because you don't know, right? Yeah, so we got Kendall and Erica, we got Brandy, Taylor, Ahmed, Ryan, Hillary, Riley, and Sinchi. There we go. We got everybody here. Not everybody, but a lot of people. It's a smaller class. Okay, so that's the tricky part, is trying to figure out when your level 2 effects become between versus contextual. That's what we're talking about. Example 2A and 2B. Then the full model. Did we go through this? I think maybe we did. I think we did. Do we want to go back over the code? Yes, big nod. Okay. People who are emphatic win. All right, I'm on step 3A, page 6. That's where we're at here. So this is the full simultaneous mediation model, including indirect effects. So things of note with respect to the code. Stress and person mean stress are on the within and between statements in the variable section because they are treated as observed variables. And this says only use it at that level. So that way it doesn't try to split it and do any kind of latent centering and put it into the other level of the model where it doesn't belong. The within model then has symptoms and mood residual variances. I've got 3 different placeholders to set up the level 1 fixed effects. So X to Y, X to M, and M to Y. I've got 2 different sets of fixed intercepts and random intercepts, one for each of the 2 variables that is treated as an outcome, which is the mediator and the outcome variable. And then I have 3 sets of fixed effects for level 1 with no random slope variances around them. Between person effects of my level 2 covariates on both the mediator and the outcome, because I can. And then contextual effects of stress on mood, X to M, X to Y, stress on symptoms, and then M to Y, mood to symptoms. And over in the next column, more code. So the steps for model constraints, I don't think I've said this explicitly, so I want to make sure that it's clear. First thing you have to do is name the linear combination that you're going to build. You can name it whatever you want, so as long as your name has 8 or fewer characters, and it doesn't start with a number. Then you build them by referring to labels that you have put on the corresponding parameters. So the labels are what are in parentheses here. It's going to refer to whatever that number is estimated to be. So then it takes that number, adds it to the other contextual effect, for instance, and these are between effects. So within plus contextual equals between. That has not changed. I know. And between minus within is what? Yeah, contextual. Yep. There's not many formulas that I ask you to memorize, but that should be one of them. Indirect effects, then, are multiplications. So this is different. It's not a linear combination because it's being multiplied, but you can do whatever you want with math and m+. So it's the x to m path times the m to y path at level 1, at level 2 amongst the context effects, and then amongst the between person effects that I just built up here. So I do believe order of code would matter. Like if I tried to do this first and these two things didn't exist yet, it'd be like, what? So just try to think logically, like things have to exist before you can refer to them. It'll yell at you, and then you'll figure it out if you get it at the wrong order. We discussed how I don't care about bootstrapping for mediation tests, but someone might, so I want to point you towards resources that will do it the rightest way. Don't have room to care. And let's go over the output for this. Let me make it big. Okay, what are these things? Within level residual variances is the label that is being used.
Level 1 residual variance.
Level 1
For
residuals?
those particular things.
For those particular things, yep. And these are the leftover kind because they're both being predicted. So this is level 1 residual variance leftover. What are these three? In the between model, symptoms on women age 80 and age 6 as the interaction. You can talk, you can type. I guess you guys can't type. Unless you log into Zoom, in which case then I can see it.
They're just cross-level interactions of the between symptoms on the other things.
They are interactions. I would not say cross-level though,
Okay.
because these are level 2 predictors. So I would call this a level 2 interaction because it's amongst 2 level 2 predictors. We actually don't have any cross-level interactions yet. Dun, dun, dun. I'm pretty sure I stuck one in here. That seems like something I would do. What about these two? Symptoms on PM stress 40 and symptoms on mood 2. Are they slopes or intercepts? We'll start there. They're slopes.
Are those direct effects?
Yeah, they're direct effects. Mhm. They are in the between model. They are level 2 predictors. I would call these main effects of person mean stress and main effect of negative mood at level 2. Are they between or contextual? One vote for between. I will remind you that we are using the placeholder notation. That's your clue. One vote for contextual. Nodding? Are you voting? Okay, another vote for contextual. Yeah, it is contextual. Whenever we do the placeholder notation like this, and you're using maximum likelihood, it's contextual. If you use Bayes, it's between. Yep. And for those of you who are familiar with Lavon, you can do MSEM in Lavon too, but it doesn't have random slopes as a thing. So that pretty much limits it to no data sets ever. This one would have worked, but that's about the only one. So that's why I'm not showing it to you. It's not going to help you. Let's see. Keep going here. What are these three? I will remind you that stress is the X, mood is the M, and symptoms is the Y. These are between effects, predicting mood. So main effects, essentially these are predicting the mood intercept at level 2. And this is a contextual effect of stress predicting the mood intercept for the same reasons. Next we get means, sort of. What are these things?
Intercepts?
Kinda. Got to vote for random intercepts. Kind of. They are the within person fixed effects at level 1. That is what they are. Now, the reason that I can say kind of intercepts and it's labeled as means is because the way this is thought of, these are the means of the variable that we created through the placeholder. The center. There's no variance around it because we did not estimate random variances for these slopes. If these were predicted by cross-level interactions, they would be called intercepts instead of means, because then they would be conditional on whatever predicting it being 0 as a cross-level interaction. So they are kind of like means or intercepts, but in a roundabout sort of way, because the variable itself is a slope. And if I knew of a way to make this less confusing, I would. I'm trying. Now these are actually intercepts. As labeled, we would call these fixed intercepts. In particular, these are the expected values of symptoms and mood when all of their predictors are 0. So you'll note that even though I'm using latent centering for mood, I centered it at 2 ahead of time because I still want my intercepts to be meaningful. So the scale of the variable has to have it. So I think it's a 1 to 5 scale, so the inference would be someone who has a 2 in their mood that day. Variances. These are not here, but because I referred to them in the code, they show up in the output. Have I not referred to them in the code, they would have been estimated because that's the default. So you have to shut them off if you don't want them. Residual variances. What are these?
The level 2 random intercept variance?
Yep, level 2 random intercept variance left over, because that's what residual means in this context. Yep. And then we get to new additional parameters. Those are the things that we created as combinations. So I first created the between effects for the level 2 model in X to M, X to Y, and M to Y, and then the corresponding indirect effects. So we have no evidence of mediation at level 1, unsurprisingly, because there's nothing related at level 1. We do have some evidence of mediation if you think about it as between, but contextual is not. So I reported all of those things. I'm not sure what someone who is from this world would make of that, but you get a little bit of inconsistency depending on how you define level 2. So what's interesting about this analysis is that the whole thing was initially phrased as daily diary, like within person stuff, but we don't have any within person findings. So this is a great example, I think, of if you had smushed this all together, you would end up with way wrong conclusions. Like if you didn't separate out the level 1 and level 2 and just put this in a standard path model, you would get some kind of weighted combination of these two fixed indirect effects together. And it would be wrong to some degree. The weighting depends on the relative amount of information at each level. It's usually going to be much closer to the within. So the within effect would be pulled positive. It would be higher than it's supposed to be by the between effect that would be embedded in it. Okay. Any questions on that? Or things you want to hear again so you can write them down? Okay. How about some interactions? This is where it gets a little tricky. Hasn't been tricky yet. I know. It's an evil laugh. So, I want to examine whether the effect of mood at each level differs by gender. That's what I want to know. That's a thing that people would do, right? This is mediation and moderation all at the same time. When I tried to do that, at level 2, M+ yelled at me. It said, nuh-uh, those are two observed variables. You got to make an observed variable interaction. And I said, nuh-uh, what I want is an interaction between the level 2 part of mood with gender and the level 1 part of mood with gender. So it's not observed. And I found a workaround that had been suggested on their, they have a discussion board where you can post problems and like they'll answer you. I have probably 4 or 5 posts on there. If you go searching, you may find me because I'm not afraid to ask for help when I need it too. So they taught me a trick. The people who wrote the software needed to trick their own software to do something. So here's the trick. I had to pretend like the random intercept for level 2 mood was a latent variable that is separate from just the random intercept. So I created, zoom in on this, a latent variable called mood int because it's the random intercept for mood. It is going to be measured at the between level by only one indicator, the actual random intercept for mood, fixed to 1. Then I shut off the intercept for the new variable and the intercept for the old variable. I shut off the variance for the old variable and I turn it on for the new one. Functionally, what I have just done is rename my variable. That's all I've done. I've taken its information about its mean and its variance and I've transferred it to this new variable called mood int. And then it works. I've had to do this a couple of times in multi-level to get interactions to work at the upper levels. And that's the only way I can get it to work. I did have to add a change to the estimation options to say algorithm equals integration to do this though. So then in the rest of the code, I am not referring to mood 2 anymore because its information has been shut off. And instead, I'm referring to mood int everywhere. So there's a few new terms in here.
Can you explain one more time why just making it a different variable like fixes anything? I guess I'm just confused about the mood int part.
It is confusing. The problem is that when I first specified an interaction between mood and gender, it thought I meant the observed version of mood that's in the data set and the observed version of gender. And so it was trying to build like a level 1 observed interaction. But I didn't want that. I wanted one at each level, and it didn't understand. So I had to trick it by pretending like this is a whole separate variable, not the between part of the observed variable that's in my data set. And I'm just transferring the information from the original random intercept that's being estimated to the new latent variable. It is just functionally renaming it. So these ones are the same. These ones are the same. Here's some new ones. 3 new lines of code right here to include 2 new fixed effects. So within person M to Y, that is the name of the latent variable that holds the slope at level 1 from M to Y. that slope is being regressed on women as an observed predictor. That is a very roundabout way of saying that is a cross-level interaction. It's like you're writing an equation for beta 1 equals, and then you'd have your fixed effect plus your cross-level interaction, and then potentially your random slope thing at the end, except we don't have random slopes. So this is an example of a systematically varying level 1 effect rather than a randomly one. I'm saying dudes get one slope, chicks get another, but other than that, they're the same. So I named this so that I could compute a between-person version of an interaction. And yes, my name is funny, but I'm trying to stick with the theme here. So within-person sexy is not what I meant, but and reading it now, it's kind of funny. You only get 8 characters. You got to like work within the system here. It stops reading after 8. Now this is brand new. I don't know if you've seen one of these. I had one model in SEM that had this with it. But I should assume you don't have perfect recall of a class you took a full year ago. Yep. This is a latent variable interaction. This is an interaction amongst a circle and a box. If one of your variables is latent, the interaction has to be latent as well. If both of your variables are observed, the interaction is observed. So I am building a new circle, essentially, a new latent variable, and I'm calling it mood sex because it is the interaction of observed gender with my renamed random intercept for mood. And xwidth is the command that builds a latent interaction term. I am then using that new interaction as a predictor of symptoms. So this is a roundabout way of saying what I have is an interaction at level 2 between the contextual effect of mood and gender. And then last but not least, building the between-person version of that as well. Okay, questions? So a lot of you are going to be using this kind of MSEM in your projects. You might be interested in interactions in moderation. Think about this process. Every time you add an interaction term, you may need to add another latent variable to the problem. At some point, it's going to break. So this is why I wanted you to have 4 to 6 variables. Keep it manageable. If you run into estimation problems, one of the things that you can do is there's a command that you can use that's called s-values in the output. One word, s-values. What that does is print as part of your output all of your code with the start values attached for what it finished with. So if you're having models that take forever to run, I would do that because then it should go faster if they're starting close to what the right answer should be. S-values is the command that will get you that. More generally, if you wanted to add start values to things, it would just be a star and then like the number. So you don't have to put start values on everything. It tends to be variances are hard to find and factor loadings tend to be hard to find. So that can help you speed things up. All right, let's see what happened. And at this point, I took pity on you and just bolded the things that are new. What is, let's see, this is the between level. So there's only just the 2 level 1 residual variances in within. What is that thing? Within person M to Y on women. It's not significant.
Being a woman on the moderation.
Uh-huh. So this is the cross-level interaction of gender with the level 1 fixed effect of mood predicting symptoms. To understand the pattern of the interaction, though, I can't just look at this number. I got to find the main effect because the interaction modifies it. So I'm going to go with gender as the moderator, and the thing we care about is the M to Y slope, the fixed slope. Where is it? Yep, it is right. You find it? Close. It's this one. It's an intercept because it's now being predicted. So we used to call this would be the main effect of the level 1 fixed effect here. So this would be for men. It's non-significant, but it's positive. For women, it is old school. Is this more positive, less positive, more negative, or less negative? Which one is it? I have a positive interaction and a positive main effect. More positive, yep. So the effect is stronger in women, but not significantly. This one is the level 2 interaction between my renamed mood intercept and gender. So the main effect would be, we go with mood, let me find that one. Oh, this one right here. It's right next to it. That was convenient. So this would be the main effect of mood on symptoms at level 2. This is a contextual effect. In men, it's significant. So after controlling for how grumpy you are today, men who have higher grumpiness than other men have higher symptoms than other men. How about in women? Ignore the p-value and tell me the pattern. Less? Is that what I'm hearing?
Yeah, less positive for.
Yep, it's less positive for women. So it's a weaker effect in women, according to the pattern. So there's only 4 kinds of interactions, and it's based on sign. If the answer is more something, it's stronger. If the answer is less something, it's weaker. And I think that was about it. Yep. So, and then here is the level 2 between person moderation, or yeah, moderation instead of contextual. And here's some words. In case it hasn't been clear, y'all aren't writing papers for your projects. You're just giving presentations. Because I don't like the idea of having you spend a ton of time writing on something if you're not sure that it's right. The idea would be, if you're using data that you care about, hopefully you'll get some feedback on your presentation that could inform a paper. And you would have the results section, but here's some examples of how I would talk about these things. Here's an equation. So this equation looks similar to what we've seen before, with a few differences. Number 1 is that I've got 2 level 1 models. I've got one for mood, I've got one for symptoms. That means I had to pick up some way of notating which outcome a given term is predicting. I chose to stick the letter on the end, M and Y. So I have an intercept latent variable for mood, a stress latent variable slope for mood, that then become level 2 outcomes down here. I have an E, level 1 outcome. Symptoms is structured similarly, except that I have mood as a second predictor, along with stress. The intercept has a bunch of stuff predicting it. These are all main effects of age, gender, their interaction, and person means stressors is the contextual effect. Random intercept variance left over, notated here as that idea. The U is a value, but the variance is what we estimate. And then just this little one right here. My fixed effect for how mood is being predicted by stress. That's what it is. And last but not least, level 2 symptoms has 3 outcomes at level 2. The intercept, the effect of stress, and the effect of mood. And note what I have at the end of this here. The effective mood, the variable that's in there, is not a variable. It's the latent variable from the model. So beta 0 I m is the predictor in this way of thinking about it. That is the part of the mood variance, or the mood variable, that was estimated at level 2. Beta 0 I is a variable. Had I not used the placeholder notation, in which mood was just the E part, that's what I would put in here too. I would put just the E. All right, questions or comments? I'm not making you write equations, by the way. At some point, it becomes next to impossible to communicate this, so. Path diagrams would be recommended. Circles and boxes and arrows would be good. It would also be helpful if you could label the arrows with, like, this is research question 1, this is research question 2 kinds of things. Like a, sort of a graphical way of displaying things.
Question.
Yeah.
Path model versus conceptual diagrams versus SEM diagrams.
Mhm.
What are the differences? 'Cause they're different, right?
Yeah, they are different. Ahmed says, equations are very helpful though. Correct. However, in a presentation where folks are going to be struggling to stay with you, it will take you all 15 minutes to explain your equation. And that can be the problem. Equations go in papers. Okay, to answer your question, so path model is sort of my general like circles and boxes and whatnot. Conceptual model would be trying to convey the major relationships but not have a symbol for every single estimated parameter. So let me get this back. This is a conceptual model. Like, I'm trying to describe what is happening, but I'm not trying to make every single parameter be somewhere in the picture. Whereas, one second. Example 4b is what I'm trying to open. Come on. There we go. This is a path model. The idea of diagrams like this is that they are a visual representation of the equation, so every piece of thing in the equation needs to be in here somewhere. In practice, I tend to land somewhere between the two. One figure that I made that folks liked, the reviewers liked, I should say. I made one reviewer happy. You got to cherish that when it happens. Nope, not that one. This one. One second. I'm opening stuff and my computer's very slow about that. Not that one. Come on. You can do it. Do you ever cheer for your computer to open things?
I've also been known as on my computer if it doesn't work with me.
Yeah, that's fair. Pictures, this. This took me like, I don't know, a day, maybe 3. This was my attempt to make a path model and the equations all in one spot so that you could like either look at this and ignore those or vice versa. But this is an example of the wrong version of the random intercept cross-lag panel model. The right version is there. So this is a wide data SEM version of the model instead. Does that help? Okay, cool. Other questions? If you apply to grants, conceptual versions are usually very helpful for your reviewers to follow. The thing that has all the parameters in it will overwhelm them. I wouldn't do that. Here is a wide data version of what we just did. Single level SEM. No, not having it? Got some unhappy faces. Well, here's the good news. In this version, you can have x be an outcome because it is an outcome and it doesn't get mad at you. This is no longer 4b, this is 5a. So rather than redo the data outside of M+, I had M+ do it. So this is long to wide. I think you've seen wide to long before, maybe. This is analogous to reshape in R or in Stata. So the old variables that I had in long format, MSEM was stress, mood, and symptoms. They become stress 1 to 5, bar to separate, mood 1 to 5, and symptoms 1 to 5. So this is wide data where 1 row per person. Every variable at each occasion is a separate column. So I had 5 occasions of 3 different variables. That creates 15. I tell it how the data were organized by ID, and then how in the time variable was, essentially. Like this, these are the values that were for time in the data set. I had kicked out the first occasion. So these are the original variables in the stacked data set, and then use variables refers to the ones in the wide data set instead, because that's what's actually being estimated. Zoom in a little bit here. Okay, with me so far? All right, some new stuff then. Categorical. You may remember this, or not. This is how you tell M+ that you have an outcome that is either binary or ordinal. It figures out what kind and how many categories based on the data. Other ones that you can use are nominal equals, if you have nominal, and also count. I think that's all of them. So what this is doing is picking the right kind of generalized model for your not normal outcome. When you use categorical, it will use a Bernoulli level 1 distribution instead of normal if it's binary, or multinomial level 1 distribution if it's ordinal. And it uses a cumulative logit link function to predict the transitions between categories. These are binary, so it's just a regular logit. The log of the odds of the probability of a 1, otherwise known as logistic regression. That's the idea here. So this is how you can do IRT models in M+, or item factor analysis models in M+. Gender by age interaction. This requires Monte Carlo integration. And now I have to refer to each of the 5 variables in the code. So the code looks quite different, even though this is the same model that we saw in 3A. This is the complete mediation model. So it's been a minute since we've talked about regular single-level SEM for growth models. But the idea is that we have to shut off the observed intercepts that would otherwise be estimated so that we can push all of their change up to the latent variables. So that's what's happening first. So I am saying don't estimate an intercept for mood or symptoms. That way all of the information about its mean is going to be captured by the fixed and random effects, the latent variables. Because stress is binary, it doesn't get an intercept. It gets something called a threshold, which is intercept times -1, and it is referred to by a $sign. When I teach this in SEM, I always make the joke, it's not really a joke, that the reason they pick the $sign is because this stuff is complicated. And if you learn it, someone will pay you so they don't have to. So, show me the money, thresholds. Then we have the variances of our variables. We are constraining those to be equal across the 5 observations for mood, and then equal to a different number across the 5 observations for symptoms. That is setting up an R matrix where the variance is constant over time on the diagonal. That is a choice. That is a constraint you don't have to make, but it's to make it analogous to the MSEM version. You don't have separate residual variances by time in MSEM, so that's what I have here. Now note I don't have one for stress. And had I written one, it would have yelled at me. Do you know why? Some of you may. This is a crossover event to the generalized class.
You technically have a residual variance where it's fixed to 2 point something.
Close. Yep, for binary data, there is no separate estimate of variance. It's determined by the mean. The variance of a binary variable is the mean, the proportion of people who have a 1 times the proportion of people who have a 0. So it's the most variance at 50-50, and it shrinks as you go out to the ends. So there is no separately estimated residual variance at level 1. What we pretend it is due to the length function. If we're in logits, we say it's 3.29, pi squared over 3. That comes from the logistic distribution as what is thought to give rise to the binary version. If you're in a probit link, it's 1. But it's not in the code because it doesn't exist. That's what you want to take home. Now we have latent factors that we're defining for our 3 intercepts at level 2. So F to me stands for factor, x, m, and y followed by int. That is my intercept factor for x, my intercept factor for m and y. They are being indicated as a latent variable, that's the by. The indicators are here, stress 1 to 5, and you can abbreviate like this, and it will fill in stress 2, stress 3, stress 4. And they're all fixed to 1 to create a random intercept. So these are factor loadings constrained to 1. That is because in the equation, there's never anything that multiplies u0. So to get it into the picture, we have to fix the factor loadings to 1 instead of some other number. We are then estimating the variances of each of these things as the random intercept variance for each variable. We are then estimating the fixed intercept for each variable as well. See, it's not so bad. Maybe it is. Okay, any that you want to hear again? Or ask questions about?
Why do some of the things have dollar signs and then some of them don't in the brackets up above just a little bit?
This one?
Yeah.
That's because these are intercepts because they're continuous variables. So each estimated, like each variable that becomes an outcome in the model, by default gets an intercept and a variance, or residual variance in this case.
Okay. And stress is 0.
And stress is binary, so it gets a stupid threshold. And if you multiply stupid threshold by -1, then it's an intercept. Logits are symmetric. So like if your logit of having a 1 is 2, then you know your logit of having a 0 is -2. That's why. Crossover event. That's the generalized class. No, I don't expect you to remember all of this. But that's why my stuff's on the internet. You can come back to it whenever you want to. Another crossover event. Measurement, psychometric-y folks. A few of you are here. What would I have called this in the SEM class? Yeah, this is a Roche model. Yep, all of the indicators have their loadings or their discriminations fixed to 1, and you estimate the variance. Yep. Theta is a random intercept. I had said at the time, this is why. So, shutting off the observed intercepts and thresholds that have information about the means of these variables so that the means can be captured right here. This is the grand mean, essentially. The fixed intercept is the mean of the means. These are the variances, latent variable variances around it are right here. Now we have these latent variables and we can do whatever we want with them. So we're going to have them be predicted by gender, age, and their interaction. Not the X one, because I couldn't do that over here. I have my level 2 mediation model. So x on m, x on y, m on y. These are contextual effects. You don't know why that is yet, but they are. And here are the level 1 fixed effects that have a very different look to them. We are not making latent variables and giving them means and variances. These are just straight fixed effects. Here's a new term, pawn. That stands for pairwise on. So it shortens the code. What it's doing is saying stress 1 predicts mood 1, stress 2 predicts mood 2, stress 3 predicts mood 3, all the way out to 5. So these are direct effects from the boxes to each other. Because these variables are all of their variance still, it's kind of like constant centering. The level 1 relationships are being specified with the whole variable. Therefore, any level 2 corresponding relationship becomes contextual. It's like constant centering. In example 5b, I will show you a very tedious workaround that results in between instead. There is a way to hack it. There always is. So x to m, x to y, m to y. So this way of writing the code highlights a choice that you don't get to make as readily in MSEM that you do here. What if you think that stress has a bigger effect of mood at the end of the study than at the beginning? Could that happen? Could the effects of level 1 predictors change over time? Yeah, that's a very reasonable thing. So if that were to happen, I would need as many labels in here as I have separate slopes. Right now, this is a constraint, not just a label. It's saying that I'm making all 5 of these pairwise slopes to be the same as they are in MSEM. So you don't have to do that. You can have a separate effect per occasion if you want. And last but not least, from here the code is the same. We have between effects and then indirect effects. And still don't care about bootstrapping, but somebody may. So this is largely equivalent, except for a few things. We now have stuff related to x being estimated that wasn't there before. So for instance, I have a mean intercept for x right here. That's my fixed intercept for x that wasn't there. I've got a variance for it. And I have a note here, this is in probits. This model, I believe, is set up to be probit link instead of logit link. So the scale of x is very different. And then I've highlighted x to m, x to y, and m to y. And note the pattern of the numbers here reinforce the idea that this is a constraint. It's 0.156 at every occasion because that's what I told it to do. Do I have to do that? No, I could choose. I could see if the model fits better if I let it be different, or different for some times and not others. That's a choice. And since we are in regular flavor maximum likelihood, any kind of likelihood ratio test for nested models is valid. So you can look at -2 log likelihood when they're all the same, compare it to when they're all different, and decide what you want to do. And so then here are the comparable results from the other model down here for the things that we care most about. So it looks like the same general idea except for that one. X to m is now significant. Go figure. And that's the end of the handout. Hooray. I know, big breath. Remember, this is the advanced longitudinal class, not the easy one. And if this were stuff that you could teach yourself in 10 minutes with Google University, then it would be a waste of your time and money to be here. Right? Kind of. So the M+ website has a whole bunch of examples of how to do various things. If you're not sure what your model should look like, I would start there and see if they have an example that is reasonably close. Unfortunately, their examples are not annotated in any way, shape, or form. So you'll just have to figure out what the code is doing in some cases. There's sometimes words in the actual manual, but usually not very many. Hey, if there were, I wouldn't have a job. What's crazy to me is that like we had to pay a bunch of money to M+ to get the license for the virtual desktop. It's like, I think around $900 a year to renew it. And from my perspective, it's like, they should be paying me because I am training their future customers. Should go the other way around. And then Jonathan would say, don't use M+, just do it in Stan. So, to each their own. All right, questions? Any of that you want to hear again or differently? No. Have we had enough then for today? Yep, deal. Okay. How about we leave a few minutes early. You can have some extra time in your lives. I know, everyone wants an extra 10 minutes or so, right? Exciting. Okay, then. I hope to see you Thursday. We'll do example 5B in lecture 5 that day, and let me know if you need anything. Okay? All right, thanks for being here. Bye for now.